Coordinate conversions, I claim you already know what they are. If you think about, okay, let's think back to vectors, you guys. When we were talking vectors, you could have a vector v be, this is good review for the final, right? A vector v be represented by a horizontal component v1, right? Or let's use just a and b, just to keep it simple. A horizontal component could be a vertical component could be b. But sometimes you weren't given the horizontal or vertical component, right? Sometimes you were just given the magnitude of the vector and the direction angle theta, and you had to come up with a, and you had to come up with b. Do you remember what the horizontal component was?
Yes. Magnitude of b, magnitude of.
You're right so far. Magnitude v times.
I know there was another magnitude within this equation.
Isn't it amazing how fast the math fades away? I've always been amazed by that. Even I don't get rusty at this class, but I do, maybe a little, maybe if I didn't teach it for 5 years I would. But I do get rusty at like Calc 2, stuff I don't teach that often. It's amazing how fast you just lose a little bit. You get it back quickly, that's the good news. But you do lose it pretty quickly. You do have to be in a constant state of review when you go on, especially when you go on in math.
Cosine.
It is cosine. It just comes from SOHCAHTOA. So the horizontal component is magnitude v cosine theta. The vertical component, magnitude v sine theta. So if you think about it, we don't have the arrow here, do we? So I'm drawing XY plane, but we often do that. We often do that instead of trying to draw concentric circles. If you know that this point is r theta in polar coordinates, and in rectangular coordinates it's x, y instead of a, b. We don't have the arrow here, do we? But the math works the same. If you draw in a hypotenuse and drop a perpendicular, you have your right triangle, and here's your angle theta, right? And then by SOHCAHTOA, for instance, you know, what do you know y is? Or let's not even go there. What trig function relates theta and y? Y is opposite side, so sine. So the sine of theta is equal to y over that hypotenuse, which we could call r, right? So what is y here? R sine theta. But guys, I mean, you need to learn to recognize, oh, that's exactly what this is, right? Different letters standing for the same sort of thing. So it's from SOHCAHTOA, once again. It's the same relationship we've talked about more than once before in a different kind of context. So what is that telling me? That's telling me that if I know what r and theta are from my point in polar coordinates, I can get the y coordinate. Y is equal to r sine theta, which is just the hypotenuse times sine theta, right? Which just means, and y is the opposite. So that just means that the sine of theta is equal to the opposite over r if you solved it for sine theta. It's the so part of SOHCAHTOA all over again. What's x going to be?
R cosine theta.
R cosine theta, the pirate said. What's the relationship between the opposite side, the y that is, the adjacent side, the x, and the theta, what kind of trig function unites them? Tangent. So what's the relationship there? Tangent theta is equal to y over x. And there's one more handy-dandy relationship that permeates the class that gives you r if you have x and y. What is that? Right, or you could just leave it in the form of the Pythagorean theorem that you're used to. R squared equals x squared plus y squared. So technically, r could be positive or negative with respect to polar coordinates, and leaving it that way really shows it, right? But you know, keep life simple. Usually just take r to be positive, unless you're forced to do otherwise. So these are your coordinate conversions. And I claim, like I say, you already know them. You just have to remember them in this context. So let's let's use one or more of those relationships. Here, we're going to convert to rectangular coordinates. You're given r theta is equal to the point 5 comma pi over 6. So what's r? So this is kind of telling you r is 5. And what's theta? Pi over 6. So if we want to convert to x comma y, right? So we want x. We want x. What formula up here do we use? R cosine theta. So I'll write down the formula and then you fill it in. I think you already did. I think you said 5, right? Cosine pi 6. When you get a special angle like pi over 6, go ahead and take the cosine of pi over 6. What is a good review for the final, right? What's the cosine of pi over 6? Root 3 over 2. So that's 5 times root 3 over 2. Or just maybe, since it's really 5 over 1, you could multiply straight across and write it as 5 root 3 all over 2. Okay, what would, in terms of what we're given here, whoops, started to write cosine. What would y equal?
R sine theta.
Our sine theta, which in this case is 5 sine of pi over 6. So that's 5 times a half, right? So just 5 halves. So your ordered pair then would be 5 root 3 over 2, comma 5 halves.